Welcome, leaders and practitioners. Today we are focusing entirely on how to maximize the benefits of generative AI by using Retrieval-Augmented Generation, or RAG. Let's uncover how to make AI trustworthy. Welcome, everyone. Let's get straight to the biggest hurdle in AI adoption, the trust gap. Generative AI is incredibly powerful, but it has a fundamental flaw. It can produce convincing but entirely incorrect information. Why does this happen? Because out-of-the-box large language models rely strictly on their original training data, which doesn't include your private company policies, live inventory, or customer histories. For businesses, these inaccurate outputs, often called fabrications or hallucinations, lead to poor decisions, massive compliance risks, and a loss of trust. How do we solve this? We must bridge the gap. We cannot rely solely on the model's public training data. We have to inject your proprietary enterprise truth into the AI's processing cycle. As senior leaders, you must understand that deploying naked, unguided AI is a risk. Our deep dive today focuses on the precise architectural patterns that eliminate this risk and turn generative AI into a highly reliable, factual business engine. Let's look at the flowchart on your screen to visualize this trust gap. On the top path, we see what happens when a user prompt goes directly into an unguided large language model. Because it lacks your internal context, the AI simply guesses the facts, leading directly to a high fabrication risk highlighted here in red. Now, follow the bottom path. When the same prompt goes into a guided enterprise AI system, the system actively retrieves your company's facts before answering. This results in the green node, an accurate and trusted response. This visual perfectly illustrates why we must move away from the top path and engineer all of our business solutions to follow the bottom path. To force the AI down that trusted path, we use a concept called grounding. What exactly is grounding? By definition, grounding means securely connecting AI responses to authoritative, verified data sources. The basics involve shifting the AI's reliance away from its generic, outdated training data and pointing it directly toward your real-time, enterprise-specific information. Why is this mandatory for enterprise AI? Because it ensures that the AI's responses aren't just plausible-sounding sentences. They are factually accurate and highly relevant to your exact business context. How do we achieve this? We technically intercept the user's natural language prompt and attach verified context to it before the large language model ever sees it. For our deep dive, I want you to use a simple analogy. Think of grounding as telling a brilliant expert that they must read your company's latest manual before they are allowed to open their mouth and answer a customer's question. This mind map breaks down the core pillars of AI grounding. At the center, we have the concept of AI grounding itself. Branching to the top right, you see authoritative data. Grounding connects the AI to specific sources like your SharePoint files, secure Dataverse tables, or curated web search. Branching to the bottom right, we see the primary outcome, verified accuracy. By pulling from authoritative data, we actively reduce fabrications and build essential user trust. Finally, the bottom left branch highlights business context, reminding us that grounding provides the real-time, enterprise-specific information that generic AI models fundamentally lack. Grounding is the conceptual foundation. Next, we will look at the exact technical mechanism used to execute it. Now we transition from the concept of grounding to the actual execution, Retrieval-Augmented Generation, universally known as RAG. What is RAG? It is the specific architectural technique used to ground a language model in your external data. The basics are right in the name, broken into 3 seamless steps. Step 1 is retrieve. The system takes the user's prompt and runs a search to retrieve relevant grounding data. Step 2 is augment. The system takes that retrieved data and attaches it to the user's original prompt. Finally, step 3 is generate. The system feeds this newly augmented package to the LLM, which uses those specific facts to generate a grounded response. Why do we love RAG? As a deep dive, RAG is incredibly powerful and cost-effective. It drastically improves factual accuracy without requiring your data science team to constantly retrain or fine-tune the massive, expensive AI model every time a company policy changes. Let's walk through the exact sequence of a RAG operation on this diagram. It starts on the left when the user submits a prompt. Look at step 2. The system pauses and reaches out to your database to retrieve matching facts. The database returns this verified data. Now, in step 3, the system performs the augment phase, combining the original prompt with the retrieved facts. In step 4, this complete, augmented payload is sent to the large language model. The LLM doesn't have to guess. It simply reads the payload to generate a factual answer. Finally, in step 5, the trusted response is delivered back to the user. This visualization proves that the AI is acting as a reasoning engine over your retrieved data, not a database of memorized facts. To make this concrete, let's look at how RG operates inside a tool you likely use, Microsoft 365 Copilot. What is the architecture here? Microsoft 365 Copilot relies entirely on the RG pattern natively. When you type a prompt into Word or PowerPoint, Copilot immediately begins the retrieve phase by securely searching the Microsoft Graph, pulling your relevant emails, Teams chats, and SharePoint files. Why? Because this grounding ensures the AI's answer is highly actionable and tailored to your specific project. How does the cycle complete? The system augments your prompt with your graph data and sends it to the LLM, like GPT-4, hosted in a secure Azure environment. For our deep dive into security, you must know that all data used is strictly encrypted in transit. Furthermore, before the user sees the answer, Microsoft applies rigorous post-processing, utilizing content moderation and safety filters to ensure the output is entirely compliant. This flowchart demystifies the Microsoft 365 Copilot architecture. Starting at the top, a user enters a prompt. It flows directly into the Blue node, grounding via Microsoft Graph. This is where Copilot securely retrieves your specific files and emails. The prompt is then augmented and sent to the LLM in Azure for processing. But notice the critical orange node near the bottom, post-processing and safety filters. Before the generated response is ever delivered back to the user's application, it must pass through this security gateway where content moderation occurs. This end-to-end flow demonstrates how RG is seamlessly integrated into enterprise SaaS products to deliver both high productivity and uncompromising safety. As leaders, you will frequently face a critical architectural decision. Should we use RG, or should we fine-tune a custom model? Let's clarify this. By definition, we must match the AI approach to the business goal to control costs and performance. The basics dictate that RG is the superior choice when your outputs must be grounded in organizational data that changes frequently. Why? Because fine-tuning a model is expensive, time-consuming, and is actually designed for a different purpose, teaching the AI industry-specific jargon or highly strict formatting. How does RG win for daily operations? RAG improves factual accuracy and eliminates fabrication simply by pointing the pre-built model at your curated content. For our deep dive, remember this distinct advantage: RAG is perfectly dynamic. If you update an HR policy PDF in SharePoint today, the RAG-enabled AI will instantly provide the new answer tomorrow. With fine-tuning, you would have to completely retrain the model to learn that new fact. Let's walk through this decision tree to solidify your AI strategy. Start at the top. What is the primary goal? If your goal is factual accuracy using live, updating enterprise data, you take the left path and use RAG. This simply requires connecting the AI to data sources like SharePoint or Dataverse, resulting in low maintenance and high trust. However, if your primary goal is teaching the AI specialized medical jargon or strict contract formatting, you take the right path to fine-tune the model. This requires curating massive amounts of training data, leading to high precision, but at a significantly higher cost. For 90% of enterprise knowledge discovery, the RAG path on the left is your optimal strategic choice. RAG is only as good as the data it retrieves. Slide 6 addresses the absolute necessity of data security in RAG systems. What does this mean? Because RAG surfaces your internal files, robust access controls are absolutely non-negotiable. The basics of trustworthy AI state that if your source data is incomplete or biased, the RAG output will be misleading. Why must leaders care? Because if your security controls are weak, a low-level employee could prompt the AI and accidentally retrieve sensitive executive payroll files, causing massive compliance failures. How do we prevent this? Enterprise RAG solutions use Microsoft Entra ID authentication. This ensures that the search index strictly honors existing file permissions. The AI can only retrieve and read documents that the specific user already has the rights to see. In our deep dive, this aligns perfectly with Microsoft's responsible AI principles, protecting privacy and designing systems with the principle of least privilege. Look at this security flowchart. It shows exactly how RAG respects your enterprise boundaries. When a user prompt enters the system, it immediately hits the Entra ID check node. The system verifies who is asking the question. If access is denied for certain confidential files, the system flows to the red block retrieval node. However, for the files where permissions are verified, the system proceeds to search data sources, safely retrieving authorized files only before generating the RAG output. This visual proves that implementing RAG does not bypass your existing SharePoint or Dataverse security. It actively enforces it at every single step of the generation process. To bring this all together, let's look at a highly practical, real-world use case, building a customer support chatbot using RAG. What are we doing? We are deploying a Copilot Studio agent grounded in your organization's data to handle complex, unpredictable queries. The basics involve setting up the bot to search official company policies or product manuals to assist employees or customers. Why is RAG a game changer here? Traditional chatbots fail and frustrate users when asked an unscripted question. But a RAG-enabled bot dynamically generates answers on the fly by reading your documents. How does it work? The bot uses natural language processing to parse what the user typed, searches your connected SharePoint sites, and summarizes the results into plain, helpful language. For our deep dive, the most critical feature of a RAG chatbot is transparency. The bot doesn't just give an answer, it provides exact source links or citations, allowing the user to click through and independently verify the facts. This sequence diagram illustrates the seamless experience of a RAG-powered chatbot. A user asks an unscripted question, "What is the new remote work policy?" The RAG bot doesn't have a pre-programmed answer. Instead, it reaches out to SharePoint, executing a search for that exact topic. SharePoint returns the official policy.pdf document. The RAG bot then acts as an intelligent reader, summarizing the PDF content internally. Finally, it replies to the user with a clear, conversational answer, importantly appending a direct citation link back to the policy PDF. This is how RAG transforms a rigid, frustrating chatbot into a dynamic, highly trusted digital assistant. For our final slide, let's examine an advanced real-world use case, executive briefing agents. What is this? We are using specialized, pre-built agents inside Microsoft 365 that orchestrate RAG across incredibly complex enterprise knowledge bases. The basics involve using tools like the researcher agent, which excels at multi-step information gathering. Why do we need this? Imagine your strategy team preparing for a board meeting. They typically waste dozens of hours manually digging through market reports, old emails, and meeting summaries. How does RAG solve this? The user simply prompts the researcher agent. The agent uses RAG to simultaneously search the Microsoft Graph and approved web sources, instantly compiling all that disparate data into a concise, cited briefing document ready for human review. Our final deep dive takeaway is this: RAG elevates generative AI from a mere grammar checker into a true digital teammate. By combining the reasoning power of the LLM with your proprietary data, RAG enables secure, scalable innovation across your entire enterprise. Thank you. Let's review this final flowchart showcasing an advanced RAG orchestration. It begins with a complex strategy team request flowing into the researcher agent. Notice how the agent branches out to simultaneously retrieve data from multiple domains, market reports, meeting notes, and internal emails. All of this rich, varied data converges into the synthesized via RAG node. The AI processes these cross-domain facts to output a highly polished executive briefing with citations. This visual proves that RAG isn't just for answering simple FAQ questions. It is an enterprise-grade engine capable of driving high-level strategic workflows and massive productivity gains.